Hi, and welcome to this video about spectrophotometers. Spectrophotometers measure how much light of a particular color is absorbed by a sample. It does this by measuring the intensity of light as a beam of light passes through the sample solution. The basic principle is that each compound absorbs or transmits light over a certain range of wavelength. This measurement can also be used to measure the amount of a known chemical substance. Before we go any further, let's look at the different components that make up a spectrophotometer. First, there's a light source. The light source typically produces white light, which is made of all the colors of the rainbow, but it could produce light outside of the colors we can see, such as ultraviolet light or infrared light. We know what the light source can produce by looking at the spectral bandwidth, which tells us the range of wavelengths. The light is directed to a diffraction grating or prism, sometimes called a monochromator, which spatially separates the light into its spectrum. The separated colors then hit a slit, sometimes called a variable wavelength selector, which allows a specific range of wavelengths to shine on the sample. This range is adjusted either by tilting the monochromator or by moving the slit. In either case, the accuracy of the spectrophotometer's measurements depend on how narrow of a range of wavelengths the slit allows through. For the most accurate measurement, the range needs to be very small. The next basic part of a spectrophotometer is the sample compartment, which holds the sample where the light can shine on it. The sample may absorb some of the light, but the light that gets through the sample is collected by a detector. The detector tells us how much light was measured for the range of wavelengths the slit allowed through. This measurement tells us what makes up the sample and other important material properties. Now that we've covered the basics, let's briefly discuss how to use the spectrophotometer. First, the sample compartment is emptied so that a reference spectrum is collected. This tells us how much light the light source is creating. Then the sample is placed in the container, the light interacts with the sample, and the amount of light absorbed is calculated by comparing this measurement to the reference measurement. Spectrophotometers come in many different shapes and sizes, but there is one particular difference I want to mention: a single beam and double beam spectrophotometer. We just discussed a single beam spectrophotometer. We have to take a reference spectrum and then put our sample in the spectrophotometer. There's only one beam of light and one detector. A double beam spectrophotometer uses two beams to compare a reference spectrum to the sample spectrum at the same time. The double beam may be created using a mirror. The mirror quickly switches between the reference and the sample. In this case, there's still only one detector. Another way to create a double beam is to separate out the light into two beams using another prism. Half the light goes to the reference and half the light goes to the sample. This way requires two detectors. Double beam spectrophotometers are more expensive than their single beam counterparts. However, you can use a double beam spectrophotometer to save time when performing experiments and help ensure the data are reproducible. Thanks for watching and happy studying.